of information for a new project, or maybe trying to get your head around a totally new subject area.
Oh, yeah. Information overload.
Exactly. And you just think, okay, there has to be a smarter way. How do I find what actually matters here?
We've definitely all been there, sifting through everything, hoping you spot the crucial bits without drowning in detail.
Well, that's really what today's deep dive is all about, finding that smarter way, especially when it comes to making sure things work properly, specifically in software development.
Right.
We're jumping into something called risk-based testing.
Yeah, risk-based testing, or RBT for short, you can kind of think of it as a strategic shortcut to quality.
A shortcut? How so?
Well, instead of trying to test every single tiny thing with the same level of, intensity.
It's often impossible anyway.
Totally impossible, especially with deadlines. So RBT helps you focus your energy, your resources, where it's actually going to make the biggest impact, making sure the really important stuff is solid.
Okay, so our mission for this session is to really unpack what risk-based testing is, why it's important, especially, like you said, when time or money is tight, and crucially, how it actually works in practice. We've dug into our source material, the matrices, to pull out the key nuggets for you.
Sounds good. Let's get into it.
All right, so first things first, what is risk-based testing? What's the core idea?
Okay, so at its heart, RBT is a type of software testing where the driving force is the probability of risk. Simple as that, really.
Probability of risk, meaning?
Meaning you look at different parts of the software and you assess them. You consider how complex is this feature? How critical is it for the business?
All the people actually use it.
Exactly. And even, based on experience, where a defect's likely to hide.
Yeah.
Based on all that, you prioritize where you put your testing effort.
Ah, okay. So it's not just testing things randomly and crossing your fingers.
Definitely not. It's much more proactive. You're essentially trying to predict, well, maybe predict is too strong, but anticipate what could go wrong.
And focus your firepower there.
Precisely. Test those high-potential problem areas more thoroughly.
Okay, the word risk is obviously central here. Can we define what we mean by risk in this context?
Sure. So a risk is basically any uncertain event, something that might happen, and if it does, it could have an effect either positive or negative on the project's success.
Success measured how?
Could be anything, really. Cost, schedule, technical performance, meeting the business goals, overall quality, you name it.
You said positive or negative effects. I usually just think of risk as bad stuff.
That's common, and honestly, in risk-based testing, we are primarily focused on the negative ones, the threats, things that could cause failure or problems.
Right.
But yeah, technically, a risk could also be an opportunity, like maybe there's a chance to adopt a new tool that speeds things up. That's a positive risk and opportunity.
But for RBT, we're mostly hunting the threats.
We are. We're trying to mitigate those negative possibilities before they actually happen.
Okay, that makes sense. So when is this RBT approach most valuable? It sounds like a bit more effort than just, standard testing.
It can be up front, but it pays off. It really shines when you've got constraints.
Like what?
Like limited time, tight budget, not enough testers. Any situation where you simply can't test everything down to the last detail.
Which is pretty much every project.
Often, yes. So you need to be smart, make choices. RBT gives you a framework for making those choices intelligently.
Okay. Any other specific situations where it's a go-to?
Oh, definitely. Security testing is a big one. RBT helps you focus on the vulnerabilities that matter most.
Like finding potential SQL injection points.
Yeah.
Or weak spots in a cloud setup.
Exactly. Those kinds of things. Also, think about new projects where there are lots of unknowns.
Maybe the team's using tech they haven't used before.
Right, or they don't have deep domain knowledge yet. Lots of inherent risk there. RBT helps manage that.
And what about projects that change a lot?
Good point. Incremental or iterative models, like Agile. RBT is perfect because as the software evolves, the risks change too. RBT helps you constantly readjust your testing focus to match the current risks.
Okay, so it's about being strategic, focusing where the potential pain points are greatest. How do you actually find those risks? Is there a set process?
Yeah, there is. And it ties closely into the overall, the broader risk management process. It starts with risk identification.
Finding the risk, step one.
Right. This is where you brainstorm, you investigate, you try to uncover all the potential things that could impact the project. And getting this right early is key.
It's a big risk here.
And your whole testing plan could be off.
Exactly. It could be focused on the wrong things.
So how do you do that? Just sit in a room and worry.
Well, maybe a bit of structured worrying. You can use workshops, checklists from past projects, brainstorming sessions are common.
talking to experts.
Definitely. Expert interviews. Looking at lessons learned documents from previous similar projects. Analyzing the root causes of past bugs can also reveal potential risk areas. Okay, so you gather all these potential risks. You need somewhere to put them, right?
Absolutely. That's where the risk register comes in. Think of it like your master list of risks.
A spreadsheet, probably.
Usually, yeah. You list the risk, maybe its potential causes, how you plan to respond to it, who owns it. It becomes your central tracking document.
And I think I saw something called a risk breakdown structure.
Yeah, that's another tool. It's like a hierarchy, breaking down the project into areas and sub-areas to help you systematically think about where risks might exist, like a family tree for risks.
Okay, found the risks, listed them in the register. Now what? You can't treat them all the same, surely.
No way. That leads straight into risk analysis. This is where you figure out which of those identified risks actually matter the most.
How likely are they? How bad would they be?
Exactly. You analyze their significance. A common tool here is the risk matrix, which we can definitely talk more about. It helps you visualize the high priority ones versus the lower ones.
Sorting the uh-oh from the...
Pretty much. It lets you see quickly what needs serious attention.
Right. So analysis tells you which ones are important. Then you plan what to do.
That's the next step. Risk response planning. Based on the analysis, how likely, how severe, you decide what actions to take.
Do you plan for every single risk?
Not necessarily. Some high-priority risks will need a concrete mitigation plan built into the project. Others you might just decide to monitor closely. And some really low ones, maybe you just accept them, do nothing for now.
And who actually does the planning and takes action?
That falls to the risk owner. Each significant risk should ideally have someone assigned to figure out the best response. A big part of this is risk mitigation.
Which means?
Trying to reduce the likelihood of the risk happening or lessening its impact if it does happen. Ideally, you want to eliminate it or bring it down to an acceptable level.
Okay, plan in place for known risks. But what about surprises, the things you didn't see coming?
Good question. That's where risk contingency planning fits in.
Contingency, like a backup plan.
Exactly. It's for those uncertain events where the impact might not even be known up front. A contingency plan is what you'll do if one of those unexpected worst-case scenarios actually materializes. It's your project's emergency kit.
Makes sense. And this isn't a one-time thing, is it?
Not at all. The final piece is risk monitoring and control. This happens throughout the entire project.
Constantly checking.
Yeah, you're tracking the risks you identified, watching any residual risks, ones that are still there after mitigation, and scanning for any new risks popping up.
And updating the register.
Constantly.
Yeah.
You update the register, investigate why things might be deviating from the plan, execute your response plans, and crucially check if those plans are actually effective.
How do you do that monitoring?
Various ways. Risk reassessments, audits, variance analysis, comparing plan versus actual, performance measurements, regular status meetings. It's ongoing vigilance.
And things can change, making risks bigger.
Absolutely. New tech, project scope creep, more stakeholders, losing key team members with specific skills.
Yeah.
All these can increase risk during the project.
Okay, that's a great overview of risk management generally. How does this translate specifically into the risk-based testing approach? What are the steps for the testing team?
Right, so the RBK approach follows that logic, but applies it directly to testing activities. It starts, ideally, with requirement analysis.
Looking at the specs.
Yep. Testers should carefully review things like the software requirement specification, SRS, functional requirements, FRS, use cases, all the documents defining what the software should do.
Why? To find problems early.
Exactly. Find ambiguities, inconsistencies, or errors in the requirements before coding even starts. That saves a massive amount of rework.
And getting those requirements formally signed off, that's actually a risk reduction technique in itself, isn't it?
It absolutely is.
Yeah.
It helps prevent major, uncontrolled changes creeping in late in the game. Any changes after sign-off should ideally go through a formal change control process, which itself is risk management.
Okay, requirements understood. What's the next RBT step?
Then comes the core part, risk assessment applied to those requirements.
Giving them a risk score.
Essentially, yes. You assess each requirement based on, well, various factors. How likely is failure related to this requirement, and what's the potential impact if it does fail?
Impact on what? Cost. Schedule.
Could be any project criteria. Cost, schedule, resources, scope, technical performance, safety, reliability, complexity. You name it. This helps you pinpoint the probability of failure and identify the high-risk areas.
And you use that risk matrix thing here too.
Often, yes. The risk assessment matrix is a key tool for this identification stage.
So you've rated the requirements by risk.
Right, and you capture all this in your risk register, keeping it updated. Around this time, you also do risk profiling.
Profiling. Like for criminals.
Huh, not quite.
Nah.
It's about understanding the project's overall appetite and capacity for risk. How much risk are stakeholders willing to tolerate? How much can the project realistically handle?
Okay, got the risks assessed and profiled. How does that drive the actual testing?
It directly fuels requirement prioritization for testing. Higher risk rating means higher priority for testing. Simple as that.
More important to test the risky stuff first and thoroughly.
Precisely. Which leads to defining the risk-based test process. You decide how you'll tackle the risks through testing.
Focusing on the big ones.
Yep. High and medium risks usually get specific mitigation strategies defined in the test plan. Low risks might just be put on a watch list or covered by broader tests. Oh, and importantly, you should also do a risk data quality assessment.
Meaning?
Check that the information you use for your risk assessment is actually reliable and accurate. Garbage in, garbage out, right?
Makes sense. So the risk level dictates the testing effort.
It does. When you get to planning and defining tests, the prioritization is key. High-risk areas often get assigned your most experienced testers.
And different techniques too.
Absolutely. You choose techniques best suited for the risk. For a complex, high-risk feature with lots of conditions, maybe you use decision tables. For a simple, low-risk one, maybe equivalence partitioning is enough.
And you design tests to cover interactions.
Yes, especially for high-risk areas. Design tests covering multiple functionalities working together, end-to-end scenarios that mimic real user workflows.
What about setting up for the tests? Data, environments.
Crucial. Test data, conditions, and bed preparation all need to happen, guided by those risk priorities. Make sure you have the right data to test the risky scenarios.
And reviewing the test plans themselves.
Very important. Review processes for test plans, strategies, test cases, even test reports are critical. Peer reviews catch a lot of issues and are a great risk reduction activity in themselves.
Maybe even doing some practice runs.
Yeah, dry runs and quality checks on test procedures or initial results can iron out kinks before formal execution.
Okay, planning done, prep done. Time to run the tests. How does risk guide execution?
Simple. Test execution follows risk priority. High-risk test cases are typically run first and might be run more often, perhaps under different conditions.
And you need to keep track of how tests relate back to the risks.
Vitally important. Maintain traceability. You need clear links showing which risk is covered by which test, what the result was, and which defects were found. This proves you're actually addressing the identified risks.
Does RBT apply at all levels of testing?
Yes, absolutely. Component integration, system acceptance testing. You can apply RBT principles at all levels. At the system level, the focus is often naturally on things like high visibility features, frequently used functions, and areas where failure would be most costly or damaging.
Okay, test run. How do you know when you're finished?
That comes down to the evaluation of exit criteria. In RBT, your exit criteria will be heavily influenced by risk.
Like all high-risk areas tested, known defects below X severity.
Exactly. You need confidence that the most critical risks are covered and the remaining or residual risk is acceptable. This feeds into risk-based reporting and metrics analysis.
Telling stakeholders how things went, risk-wise.
Precisely. Reporting communicates results, compares them against objectives, and highlights the status of the risks. Metrics help you analyze the effectiveness of your RBT process.
And you keep reassessing.
Always. Reassess existing risks, identify new ones based on test results or key risk indicators, and keep that risk register updated.
It really sounds like a continuous loop.
It is. You also need those contingency plans ready for high exposure risks. If defects are found, defect analysis and prevention helps you learn from them.
And retesting.
Retesting and regression testing should also prioritize based on risk. Make sure fixes in high-risk areas didn't break anything else important.
Can you automate parts of this?
Sometimes. Risk-based automation is possible, focusing automation efforts on stable, high-risk regression suites, for example.
Then you figure out what risk is left.
Yep. Residual risk calculation. What's the risk level after testing? And ongoing risk monitoring and control continues. You might even reassess the risk profile and definitely gather customer feedback.
Until finally.
Finally, you need your exit criteria, defined largely by risk. Key risks addressed, exposure acceptable. Then you can consider testing complete for that phase.
You mentioned system testing specifically. How does RBT apply there?
Right. At the system test level, RBT helps prioritize across different types. There's technical system testing environments, interoperability, functional system testing, does it do what it's supposed to, and non-functional performance, load, security, usability, backups, documentation.
So RBT helps decide, say, whether to spend more time on performance testing versus functional testing for a specific release.
Exactly. Based on the identified risks, maybe a performance failure is considered catastrophic, or a specific functional area is complex and prone to bugs, you allocate your effort accordingly.
Okay, I think I get the overall flow. Can we zoom in a bit more on the how, like the nitty-gritty process?
Sure, it boils down to those key phases:
Mhm.
risk identification, analysis, response. But within testing, a really crucial activity is test scoping.
Scoping, deciding what's in and out.
Precisely.
Mm.
It's a review involving key stakeholders, the technical team. Everyone agrees on which risks the testing activities will explicitly address.
Why is that so important?
It sets expectations. You need to document dependencies, the requirements being covered, the estimated cost and time for testing those agreed upon risks, and clearly state what won't be covered. Everyone needs to be aligned.
Right. Prevents arguments later about what testing was supposed to achieve.
Totally. Let's use a quick example. Imagine you have functional requirements F1, F2, F3 with associated risks R1, R2, R3, and non-functional ones N1, usability, N2, security, with risks NR1 and R2.
Okay.
For each pair, like F1, R1, you define a test objective. Maybe it's demonstrate F1 meets user needs and mitigate risk R1. The actual test activity might be execute user workflow tests across browsers for F1.
And for security, N2 and R2.
The objective might be verify system operational security controls mitigate risk NR2. The activity could be perform penetration testing focusing on common web vulnerabilities. See how the risk drives the specific test goal and action.
Yeah, that connects the dots nicely. So how do you actually create that detailed risk register you mentioned earlier?
Okay, designing the process. The risk register gets built from various inputs. You might start with generic risk lists, industry checklists, definitely brainstorming with the project team.
And you'd include both functional and non-functional risks.
Absolutely.
Yeah.
Usability issues, security holes, performance bottlenecks, those are all risks that need to be considered alongside does the feature work risks. Each gets a unique ID.
And you fill in the columns, like probability.
Exactly. Key columns often include probability, how likely is failure, often a simple scale like low, medium, high.
The consequences.
Same idea.
Yeah.
What's the impact if it fails? Low, medium, high again. Or maybe categories like marginal, critical, catastrophic.
And exposure.
Exposure is usually calculated.
Mm.
Probability times consequences
Yeah.
gives you a raw risk score.
What about test effectiveness?
That's an interesting one. Test effectiveness is the tester's confidence. How sure are they that the planned tests will actually find problems related to this risk? Again, maybe low to high.
And that leads to the priority number.
Right. The test priority number often combines these. Maybe probability X, consequences X, test effectiveness. It gives a weighted priority.
What else goes in the register?
You'll define clear test objective for each risk. What specific goal is the testing trying to achieve for this risk? You list the test techniques planned, note any dependencies, special skills, tools, environments, data needed, estimate effort and timescale. And finally, the test stage unit, integrations, system, etc.
So that test priority number really drives the focus.
Hugely. Calculating that number lets you rank the risks. You can then classify them high red, medium, yellow, low green. This directly informs test planning and execution order. It helps make those crucial scoping decisions, what's in, what's out for this round of testing.
And for each test stage, you define the specifics.
Yes, objectives for that stage, components under test, responsibilities, environment needs, entry-exit criteria, tools, techniques, deliverables, all planned out, informed by the risk priorities.
You mentioned generic test objectives earlier. Could you give a few more examples?
Sure. These are broad goals that often apply across different projects. Things like ensure component meets its specified requirements, or verify that integrated components function together correctly.
For the whole system.
Like confirm the system meets specified functional and non-functional requirements, or even higher level, validate that the product satisfies end-user needs in the target environment.
Are there generic objectives related to the process itself?
Yes, like ensure the risk management strategy is effectively implemented, or meet regulatory or contractual obligations. And, of course, the classic project goals. Achieve cost, schedule, and quality objectives.
So they provide a sort of high-level checklist.
Kind of. They help frame the purpose of testing at each stage: component, integration, system acceptance. For system testing, for instance, generic objectives would link back to verifying those key functional requirements, F1, F2, F3 in our example, and non-functional ones, N1, N2.
Got it. Now, that risk assessment matrix, the probability impact one, let's visualize that.
Okay, it's usually a grid. One axis is probability, likelihood. The other is severity, impact.
And you plot each risk on it.
Exactly. The risk rating itself is often just probability multiplied by severity, placing the risk into a specific cell on the grid.
How do you define the scales for probability and severity?
The source we looked at had some useful categories. Probability could range from, say, frequent or probable down to occasional, remote, or even improbable, maybe with rough percentage likelihoods attached.
Like severity.
That reflects the consequences. Could be catastrophic, like threatens project viability. Critical causes major disruption or loss. Marginal causes some manageable harm. Or negligible, very minor impact.
And where it lands on the grid gives you the color code: red, yellow, green.
Precisely. The matrix zones define the priority. Maybe the top right corner, high probability, high severity, is red, high risk. The bottom left, low, low, is green, low. You might have yellow, medium, and maybe even an amber, serious category in between.
And each color suggests an action.
Generally, yes. Red, serious might mean stop and fix immediately. High could be requires immediate management attention and mitigation. Medium might be minimize where feasible, monitor. Low could be monitor periodically, accept.
That visual must be so helpful for communicating.
It really is.
Yes.
Cuts through the complexity. We also found a helpful generic checklist for RBT.
Oh. What kinds of things are on it?
It prompts you to think about key areas, like what are the most important functions? What's most visible to users? Areas with safety or financial implications. Complex bits of code.
Things you can test early.
Yep, features testable early on. Any last-minute changes always risky. Problems seen in similar past projects. Anything impacting operation or maintenance costs. Poorly defined requirements are a big risk flag.
Worst case scenarios, too.
Definitely. What's the absolute worst that could happen? What causes the most customer complaints? What should end-to-end tests focus on? How do you get the best test coverage for the time available? It's a great sanity check.
Okay, fast forward. Testing is done, or a phase is done. How do you report the results effectively using RBT principles?
Risk-based testing results. Reporting isn't just about pass-fail counts. It's about communicating the outcomes in the context of risk.
So connecting results back to the risks they covered.
Exactly. Key information includes planned versus executed tests, especially for high-risk areas, pass-fail counts, again, filterable by risk, defect details, status, severity, which risk area they relate to, list of open critical defects, environment issues, any showstoppers. You typically have summary reports and coverage reports framed around risk.
And what about metrics? What should you track?
Good RDT metrics help you measure how well your strategy is working. Things like effort schedule variance, did focusing on risk save time, test case productivity, test design and execution coverage, how much of the risk did we cover?
How good were we at finding risks?
Right. Risk identification efficiency. Risk mitigation efficiency. Overall test effectiveness. Did we find the important bugs? Defect leakage? How many critical bugs slipped through? Requirements stability. Even cost of quality viewed through a risk lens.
So you'd analyze defects based on risk areas?
Yeah. Analyze defects found in high-risk functional areas versus low-risk ones. Track pass-fail rates for tests associated with different risk levels, and critically, identify and monitor those key risk indicators, KRIs, the lead and lag indicators that warn you about emerging problems.
You also mentioned inherent versus residual risk earlier. Can you quickly recap that?
Sure. Inherent risk is the risk that's naturally there before you do anything, before controls, before testing. Residual risk is what's left after you've applied your controls and done your testing.
The leftover risk.
Exactly. There are also secondary risks, new risks, created by your response to an initial risk. And recurrent risks, the chance an original risk might pop up again. Measuring test results against these helps you understand the remaining quality risk and make that informed release decision.
That makes sense. You need to know what you're still potentially facing. How does customer feedback tie in?
Well, risk profiling, as we said, is about balancing risk appetite and capacity. Getting customer feedback is gold dust here. It provides real-world input on what users perceive as risky or problematic, which can refine your future risk assessments and testing focus. It closes the loop.
Okay, let's pull it all together. What are the big advantages? Why go through this structured RBT process?
The benefits are pretty compelling, actually. First off, improved productivity and cost reduction. You're not wasting time testing trivial stuff.
Faster releases.
Often, yes. Faster time to market because you focus on getting the critical parts stable sooner, better service performance, and definitely higher quality, especially for those crucial functions.
And better information.
Absolutely. You get clear test coverage information tied to risk. It helps allocate test effort efficiently. Management gets informed release decisions based on known residual risk.
Optimize testing overall.
Yes, optimized testing. It can lead to improved customer satisfaction because the things they care most about, often the high-risk areas, get tested thoroughly, and they can be involved in the risk discussions.
Finds problems earlier, too.
Early problem detection is a major plus. And the continuous risk monitoring throughout the life cycle keeps the project on track and helps achieve goals.
So wrapping it up, RBT seems like a much smarter, more focused way to approach quality assurance.
That's the perfect summary. Risk-based testing is an efficient strategy to guide projects based on risk. It organizes testing by linking prioritized risks directly to test activities.
And execution follows priority.
Execution follows risk priority, and ongoing monitoring tracks and helps manage those residual risks. It's about targeted effort for maximum impact. Okay, let's bring this back to you, the listener. Remember wanting that efficient way to grasp complex info. Well, the key takeaway here is that RBT is exactly that for software testing. It's smart, it's focused.
Right. Instead of boiling the ocean, you strategically pick your battles based on likelihood and impact the core of risk.
Precisely. And for you, understanding this gives you a powerful lens. You can see how identifying and tackling risks up front saves time, money, and potential headaches in any project, not just software.
It provides a practical way to manage quality without getting bogged down in testing absolutely everything.
So maybe take a moment to think. In the projects or areas you're working on, where could applying a risk-based mindset have the biggest payoff?
Yeah, and how might really understanding the potential risks change how you approach tackling new challenges or learning new things? Something to mull over.
Definitely food for thought. Thanks for joining us for this deep dive into risk-based.